Okay, hi, I'm Tara McGivern, and this is my screencast for CA2 of Distributed Games Programming. So I've been working on this game with Michael for the past few weeks, and it's a continuation of our CA1. So it's called Castle Quest, and you're this Robin Hood character. And to make it more of a multiplayer game, the main level is a lot longer. There's a lot more enemies, so it's quite tough to complete on your own, but you can do it if you want. And it's made for 4 players to play online. So one of the first things I'm going to show you is actually capabilities to join the game. So we use TCP protocol, and it handles 11 different packets. The original default game handles 12, but I chose to remove one of those, in a way removing kind of an extra task for the server to handle, and in hopes that I would improve game state and synchronization and kind of game persistence, because it doesn't need to worry about spawning enemies. That is now handled in the world class. So I'm going to join a game right now. So I've just hosted it on another machine, so I should be able to join. For the purpose of the screencast, I've muted the music because it's quite loud and it makes it quite difficult to talk over it. So I'm player 2, and yeah, this is kind of the online. So one of the improvements from the last game was actually gravity. So I have no problem landing on the boxes, but the biggest thing is I can no longer jump through the bottom of them, so no matter how hard I try, I'm staying on the ground. Okay, so I'm going to talk through the code of how we did this game. So one of the first things was storing the player information in a structure called character info. Each character info structure had their position, their hit points, missile ammo, real-time actions, and each one of these was stored in a map. And the first pair in the map was in the player number, which functions as the key. Now, originally, I wanted to store the player number, so I had actually added another field to the character info. However, this started creating an error that whenever I would play the game online and I had a cooperative, like a local co-op player, I could not complete it. And that's when I discovered I could use the player number. Now, player number was very important because the multiplayer aspect of the game, as it being a race to the end level, I had to have some way of storing each player's results. So I did this with a queue. So queue is the first in first out structure, and I actually just kind of changed how I went about the mission success packet. So in the tick function, actually I will show you the queue is initialized in game server, or it is first declared here as pole positions, and it is initialized when at the start of the class here, and we use it in the tick function. So the end level is at 4000, and this is where the castle is. So I'll check each player's position along the x-axis, and if they're greater than 4000, I will put them in the queue. Now the first thing I check is if the queue is empty, I will just put whoever passes there first in, and if it's not, I will check the first element of the queue and see if it equals the player number that I'm currently at, and if it doesn't, I'll put them in the queue. So this way we don't store a player that has finished the level long before anyone else. And then when every player has finally got past this point, we'll set this all aircrafts done boolean to true, to true, and then when that's the case, we will open a text file and write this little header, and then we will pop the top of the queue and put out the results. So the queue, yeah, is quite simple in a way that it maintains the whole kind of the positions at which people finished without me having to store that as another element in the data structure. So yeah, I noted earlier how I, usually here we would handle a very large piece of code that would spawn enemies, because the original game would spawn enemies kind of randomly at the top of the screen. But in my game, I wanted to have a place for each enemy, as it is a 2D side scroller and it's got a lot of platforms in it. I don't want an enemy to randomly spawn in midair when a platform has been spawned, and I also don't want to randomly spawn the platforms as well, because it could create a very messy level. So in the add platforms and add enemies method, there was a if statement for if network world return, so it would instantly jump out of this method and not add any of the platforms. But when I remove this, it will add the enemies and platforms exactly where I want them. So this also adds another element to the game, and that is strategy. So as the layout is the same every single time, it kind of encourages players to cooperate amongst each other and maybe plan how they're going to get through it. Especially if it's a race, there's obviously different ways. If they jump on this platform, will it be much quicker, and so on and so forth. So another little note about game persistence would be how I make use of the game identifier, or the get identifier function in the aircraft class. So up here we can see it, and it basically returns the number of that player. So player 1, when we call get identifier, we're going to get 1 back, and so on and so forth. And I added a player number display, and it would display above each player's head, and this would update like the other kind of display texts, and kind of help players distinguish between each other, because the character sprite is the same. So you need something, because everyone is Robin Hood, you need something to tell who is who, and this updates, but it just adds a P for player in front of it. I tried not to give any other data to handle across the client and server. I didn't want to overload it. I was trying to kind of improve it by removing stuff like the spawn enemies and having that all handled by the world class. Other little bits I did to improve the game were the gravity. So like you could see, you could not jump from the bottom of the platforms, and you could land, and that is taken care of in the handle collisions class, or handle collisions method. So if we just go there now, I check for collision between a player and a platform, and I check if the player is above the platform in the first scenario, and if they are, well, they can land on it if the difference between their Y positions is greater than 0 and less than 5. Originally I had this set as 1, but it was real hit or miss as to whether the player would actually land on the platform or not, so 5 was a much bigger kind of margin in which they could fall. And if the player is touching the platform, but their Y position is at the very bottom of the world, which I know is 728, then I'm going to set this variable not touch platform to true, and that way they can't jump up any further. So in the player class, we can see this at the very top. So if they're not touching the platform, let them jump. And then at the end we always set it back to false, because if you don't, even when you walk out from the platform and there's nothing above you, you wouldn't be able to jump. So other things to note is this game handles gamepad functionality, or joystick functionality as SFML calls it. It supports 4 players online, and each player can have one local cooperative player. So in total there could be 8, but 4 would be a nice number, as the level is quite long, but not incredibly long. It could become overcrowded. I think that is all. Thank you for watching.